Alright, so for our first example of dimensional analysis, we're going to look at how many meters are in 25 millimeters. So we're going to go through the standard process that you go through for any dimensional analysis. So start by making our train track. And we're going to start with our given, which is going to be 25 millimeters. So if there are 25 millimeters there, there's no other unit attached to here, so we don't need to worry about doing anything with the bottom. We then know automatically that this unit here is going to come over to the bottom. So millimeters has to go to the bottom of the other side. That way it can wind up canceling out. Now I'm trying to get to meters. Because meters and millimeters are both standard metric units, we can go straight between them because they both end with meters. It's just the difference of milli versus the base. So I can go ahead and put that there. Now remember to do metric conversions. We're going to figure out which one's bigger first. So looking at the that diagram on the back of your periodic table, if you look, you can see that meters is further to the left, meaning that it's the bigger one. So we're going to say for every 1 meter. Then we need to look at millimeters. So if we count dashes over, you'll see that the milli is 3 dashes over from the base unit. So that means that we're going to add 1, 2, 3 zeros, or that there are 1,000 millimeters in a meter. Let's make sure our units cancel. So we have millimeters both on top and bottom, so those go away. We're left with meters, which is what we want. So then we just simply work out the problem. So multiply the top together. 25 times 1 meter. It's going to be 25 meters over 1,000. Then whenever we go to do that math, 25 meters over 1,000 should get 0.025 meters, and there is our final answer. Okay, so for the next problem, we want to look at how many milligrams are in 0.489 kilograms. So again, we're going to start by setting up the train tracks. Putting our given, which is 0.489 kilograms. We'll automatically move kilograms down bottom. Now, we're trying to get between kilograms and milligrams. So these are both metric units because they both deal with grams. It's just one is kilo and one is milli. So you have 2 options to go from here. Some people like to use the base unit in the middle, so in this case that would be grams. So some people want to go from kilograms to grams, then put grams down here, and then milligrams up top. But since it's all metric, you can go straight from one to the other. So we're going to go ahead and just go to milligrams. Now, with every other metric thing, we need to look at what we've got. And so we know that for every 1 kilogram, because kilograms are bigger, they're farther on the left, which means that they're going to be bigger than milli. And when we count the dashes over, we see that there are 6 dashes to get over 2 milligrams. So that means that we get a total of 6 zeros, meaning that there are 1 million milligrams in 1 kilogram. Let's cancel our units, make sure things work. We're left with milligrams. That's what the final answer is supposed to be because we're looking for milligrams. So we know unit-wise we're good to go. Multiply the top, multiply the bottom. 0.489 times 1 million is going to be 489,000 over 1. 489,000 milligrams. Don't forget your units. And if, of course, anything divided by 1, 489,000 milligrams is the final answer. So a little trickier now. How many fluid ounces are in 0.0078 liters? And then we've got a couple conversions here. 1 cup is 8 fluid ounces, and then there are 236 milliliters per cup. Okay, so as always, start with our train tracks, set them up, and we know that our given value is going to be this 0.0078 liters. So we'll go ahead and put that there. and liters can automatically go down bottom. Now this one's a little trickier because we don't have a way to get straight from liters to fluid ounces. I'm sure you could Google it, but you're not going to have Google on your quiz or test. So we've got to use what is given to us. So I can see that there are cups, fluid ounces, milliliters, and then cups again. Whenever you have something a little trickier like this, it can be helpful, especially when you're first starting, to make a roadmap, a sort of roadmap, of where you're starting and where you need to end. So I know that I'm starting at liters, and that I somehow need to end at fluid ounces. So I need to figure out what goes in between those. So as I'm looking at my conversions, I don't see any liters up here. Some of you may see milliliters there, and that could be a potential way to go. But just to play it on the safe side, let's stick with stuff that we know. So we can see fluid ounces is connected to cups. I have a conversion to do that. So I know that in order to get to fluid ounces, I'm probably going to need to get to cups at some point. Because again, I have that conversion there. I don't have anything to connect liters and cups though, but I see I have cups again. Cups and milliliters are connected with each other. So we can go from milliliters to cups, and then now I've got liters and milliliters. Those are just standard metric units, so I know that I can go between them. So now I've got my order. I know I'm going to go from liters to milliliters, then I can use this to go from milliliters to cups, and then I can use my cups to get to fluid ounces. So we can go ahead and just get the rest of the train track set up at this point with units. So I know milliliters is next, then milliliters to cups. And it's up to you if you want to do all the units first or if you want to take it step by step. I like to get the units done so I can just fill in numbers later. Then cups to fluid ounces. Okay, so that's all the units. Now I need to do my conversions, and I've got 3 different conversions, so I need to be careful and make sure I put the right numbers in the right places. So here we've got our standard metric one. I know that liters are bigger than milliliters, so I'll go ahead and put the 1 there. And then for milliliters, it's 3 dashes over to get to milli, so I'm going to put 3 zeros so that I get 1,000 milliliters in a liter. Next is the milliliters to cup, so I'm using this one here. So being careful to make sure I put the numbers in the correct places, I need to look and see what numbers are associated with what unit. So as I look at the milliliter, the only number that's actually associated with it is the 236, because it's literally right next to the milliliters. So 236 belongs with the milliliters. Then I look at the cup. Now there's not a number right next to it because it's just per cup. But just like everything else in math, remember, if you just have x sitting in an equation, so you know that there's actually a 1 kind of hidden there. We just don't write it because mathematicians and scientists are lazy. And so when there's a 1, it's just automatically known that it's just simply x or something like that. So this is saying that there are 236 milliliters per cup. So that means per every 1 cup. Then going between cups and fluid ounces, I can see 1 is with the cup. I can see 8.0 is with the fluid ounces. And then from here, let's cancel our units to make sure. So I have liters on top and bottom, so that's okay. I have milliliters on top and bottom. Cups on top and bottom. The only unit I have left I haven't crossed off is fluid ounces because there's no fluid ounces down on the bottom. And that's what I'm looking for. So I know at this point that I'm good to go. So now we just simply need to plug it in. So 0.0078 times 1,000 times 8 for the top. And the top is going to be, go ahead and get rid of our roadmap here real quick since we're done with it. Already set up the train tracks. So the top is going to be 62.4 fluid ounces over, then the bottom, 1 times 236 times 1 is 236. So we do 62.4 divided by 236, and we wind up with an answer of 0.2 0.226 to match up with our significant digits. Make sure we've just got the 2 there. Fluid ounces. And there we go. So, even when you have a more tricky thing like this, sometimes doing that roadmap at the beginning can help, but it's literally just plugging in stuff and making sure that you have the right number with the right unit by literally just looking at what number is right next to the unit. That's all there is to it. Alrighty, so last problem. So we want to determine the number of flargles in 23.7 bumps. These are completely made up units, they're completely random. Conversions here are completely random, so a problem like this will prevent you from being able to look it up on Google because it simply doesn't exist. So something like this would be the reason why you have to make sure that you actually know how to use your dimensional analysis. So, again, as always, start with the train tracks. And we know from the problem that we're starting with 23.7 bumps. And then we know that bumps are going to have to come down there. Now again, this is a more tricky one. So we're going to go ahead and do our roadmap. So we're starting with bumps. And we know that we need to end with flargles. So we somehow need to get from here to there. So as I'm looking at my conversions, I can see a bump here. So I have a comparison between bumps and bowls. So that might be a good way to go. Then I'm looking for either bowls or flargles. And so I can see, oh, I've got a flargle here. So if I'm in tups, I can probably get to flargles. Now, is there something that connects bowls and tups? Well, there is, right there, bowls and tups. So I know that this is the path that I need to take in order to get there. So I need to go from bumps to bowls, then to tups, and then end up with flargles, and I should be good to go. So I know bowls will go up there. Then of course it automatically comes down. Tups is the next unit on my roadmap. And then it automatically comes down because that's not our final unit. And then we can get to flargles. Now we check out our conversions, figure out which numbers go where. So between bumps and bowls, I saw I had this conversion here. It says there are 2 bumps per 97 bowls. So the 2 is going to go with the bumps because, again, that's literally the number that is right next to it. It is that simple. So 2 goes there, and the 97 goes up top. Between tups and bowls, we've got this conversion here, 59 tups equal 3 bowls. So 59 tups for 3 bowls. And then lastly, 1 flargle is 87 tups. So the 1 goes with the flargle, the 87 goes with the tups. From here, we can just do multiply the top, multiply the bottom. So 23.7 times 97 times 59 times 1, it equals, let's go ahead and make us some room. $135,635.1. Oh, and we forgot to check our units. Bumps cancel out, bowls cancel out, tups cancel out. We're left with flargles, so we're good there. So 135,635.1 flargles over 2 times 3 times 87, which is going to be 522. So we divide those two numbers, so 135,635.1 divided by 522, and we wind up with 259.84, but we need to make sure that we're rounding to right sig figs. We started out with 3, everything else was conversion, so that 3 is what we need to end with. So we're actually because that 8 will bump up the 9, but then the 9 turns to a 0, so that bumps up the former one. So 260 with a decimal point. Flargles. So we got our 3 sig figs, and we are good to go.